Hello students, welcome back to your online session of physics class for today. Now continuing with our chapter number 5, let us first of all recall what we did in our last class. In our last class we learned and studied about luminous and non-luminous object and then rectilinear propagation of light. It means how light travels in a straight line, right? And we also saw about examples and applications of rectilinear propagation of light. Now today we will see and learn about pinhole camera. We will see about its construction, its working and its use and also its definition. So let us get started. Pinhole camera is the earliest camera to be made. It is a direct consequence of the rectilinear propagation of light. Okay, so actually the earliest camera that we used to have was pinhole camera, and it works on the principle of rectilinear propagation of light. An ordinary camera has a lens that makes an image on film. In pinhole camera, a small hole replaces the lens. It means in pinhole camera, a lens does not used to be there. Okay, only a small hole in place of lens, and it is based on the principle that a recognizable image is formed on a screen if light is allowed to pass through a small opening or hole. So the principle that works in pinhole camera is that image, like whatever image we need to form inside the camera is placed in front of the camera, and then if we will allow the light to pass through it, then through the opening or a hole, then the image will be formed inside the camera also. Okay, the ray diagram showing the formation of image by a pinhole camera is shown in the figure. The image formed is always erect. It means whatever image will be formed in the pinhole camera will always be inverted, means opposite. Okay, now let us see its ray diagram. See, this is an object of which the image we are going to form. Okay, and this box will be a pinhole camera, and this will be the hole. Okay, so whatever image we will get inside the pinhole camera will be opposite. I hope you all can see it. The image that has been formed inside the pinhole camera is opposite. Okay, so this is the ray diagram of pinhole camera. Now let us see its construction. A pinhole camera consists of a rectangular box made up of cardboard or wood or metal closed from all sides. So for just to construct a pinhole camera, what we need to do, we need to take a we need to make a rectangular box, okay, either of cardboard or wood or metal. But we need to make sure that the sides, all four sides should be properly closed. Okay, not even little bit hole or space should be left in between. Now on one side of a box, a screen of semi-transparent paper or grounded glass is fitted. On in any one side, like of the rectangular box, we need to fit semi-transparent paper or grounded glass. Okay, the side opposite to its face has a small pinhole. See, consider if we will put that transparent paper or grounded glass over here, then at this part the hole should be there. Now you can see we have hole over here, so it means at that side they have kept this glass. Okay, now the box is properly sealed so that no light enters it from anywhere except the pinhole, and we need to make sure that these corners are properly sealed so that no light other than this will enter the box. To avoid reflection of light inside the box is blackened from inside. From inside, the box can be painted. The box must be painted black just to avoid any reflection of light. When you are not taking a picture, you need to cover the pinhole with black paper. This is how what they have done. They have made a cover over here. So whenever they are not taking any picture, we need to cover it. Now let us see its working. How does a pinhole camera works? When a candle is held in front of hole of camera in a dark room, a small inverted and real image of the candle is seen on the screen. Now see, in this thing though we can also see over here. This is a pinhole camera, right? Like this is the construction of the picture. The hole is over here. Now what they have done, they have kept a lighted candle over here, right? I hope we all can see it. So the image that has been formed is inverted, or I should say opposite, right? Let us read it further. Narrow beams of rays from the entire candle pass through the pinhole to form this inverted image on the screen. So what will happen, that the beam of rays from entire candle will pass through the pinhole, and then what will happen, an inverted image will be formed on the screen. If the camera is moved forward towards the candle, decreasing the distance of the object from the camera, the size of the image increases. Now what we need to do, see, just consider like this is a pinhole camera, okay, and earlier the candle was placed over here, so the image would have formed over here, right? But the size of the image would be bit small, okay. Then what we'll do, we will bring that candle closer, okay. Let us keep it here now. So what will happen, the size of the image or size of the candle will be formed here, and the size will increase, okay. And if the camera is moved backwards, increasing the distance of the object, the size of the image decreases. Now if we will just take the candle away, the size of the image that is formed over here will decrease, will become more small, okay, much smaller than earlier, but the image remains clear and focused. But what will happen, the image will remain clear and focused, okay, sharp. So there is no focusing adjustments needed. Now see, in our camera, which even I am using over here, see, over here it is becoming bit blur, but then focusing, when I am focusing it, it is becoming clear. But in pinhole camera, that focusing or adjustments are not needed, okay. Only like in our latest or the like updated language, we can say zoom in and zoom out. We can do by just adjusting the place of the camera or the place of the candle or the object, okay. But that focusing or adjustments are not needed. Since the image is formed on a screen, so we say the image is real, okay. It should be remembered that as long as the size of the hole is small, the shape of the hole does not affect the image. It means, see, while creating or just while making the shape of the hole, it might, like we might cut it in this shape or maybe in this shape which is not perfectly circle. In perfect circle the image will be perfect, right? But even in these shapes also the image will be perfect. It means the shape of the hole will not affect the shape of the image, okay. Now these two are the pictures of pinhole camera. This is how they have showed us that how image is formed inside the pinhole camera. Now the size of the image is directly proportional to the distance of the screen from the hole. It means that if we will increase the size, if we will increase the distance, then uh, the size of the image will also decrease. But if we will decrease the distance, then size of the image will increase. And it is inversely proportional to the distance of object from the pinhole, from the distance of the object from the pinhole. We just need to increase or decrease the object from the pinhole, and then the image will also increase or decrease the size. Okay, now directly proportional to the size of the object. And yes, size of the object also matters. Okay, if it will be huge, then it also will affect the size of the image. Okay, so this is what we have learned about pinhole camera. Now our next topic is shadows. What exactly are they? This topic we will cover in our next class, because along with this we will also learn about umbra and penumbra region. Okay, and then after that we will move on to eclipse, and this will be our last topic of this chapter. Okay, so that is all for today, students, and prepare well for your test, and please read this one. Okay, this pinhole camera, please read it properly, and then we will begin with our next topic in our next class. Have a good day, students. Take care.